So, hello everyone, this is Zahid Bashir. I am a PhD scholar at Delhi College of Commerce, University of Punjab, and I am a faculty member at University of Gujarat, Department of Commerce. So, today is basically the 26th of April, and we are at the intermediate level with 21st day training day with the time of 9 p.m. to 9:40 p.m. So far, we have discussed all these yellow colored fonts up to the mean comparison, and we have started correlation analysis yesterday, and we have completed it. Today, we are going to discuss the simple and multiple regression analysis. And on Monday, because today is the last working day of this week, we will consider the next topic, which is regression assumption or diagnostic on Monday. And after that, regression cases, EFA, discriminant analysis, cluster analysis, process by Hayes, and the last but not the least, that is power analysis, which is sample size estimation. So we have discussed the bivariate analysis yesterday. So today we are going to discuss the regression analysis in detail, how to consider the regression and how to test your hypothesis using regression analysis. So first of all, you need to understand what is the regression analysis is and how we can consider it. So let's start the topic from here. Regression analysis. So regression analysis is a statistical technique used to model the relationship between a dependent variable and one or more independent variable. The goal is to understand and quantify the nature of the relationship as well as to make predictions or estimate the values of the dependent variable based on the values of the independent variable. In simple terms, regression analysis seeks to find the best fitting line or curve that represent the relationship between variables. This line is called the regression line and it serves as the predictive model. So the basic idea is to identify how changes in one or more independent variable are associated with changes in the dependent variable. So here, a number of independent variables are going to influence the dependent variable. So there are two types of regression analysis, simple regression analysis and multiple regression analysis. In simple regression analysis, it involves a single independent variable which is predicting the variation in the dependent variable. The relationship is represented by a straight line, and the model looks like this, where y is dependent variable is equal to beta naught, which is basically the constant term, plus beta 1 into x. X is your single independent variable, while beta 1 is the slope coefficient, which is measuring the variation of your independent variable. Then there is error term, which includes all those factors or all those variables which are not considered in your model. So y is the dependent variable, x is the independent variable, beta naught is the intercept or constant, and beta 1 is the slope, and e is the error term. While in case of multiple regression analysis, it involves multiple independent variable predicting the variation in the dependent variable. The relationship is represented by a hyperplane in the multidimensional space. The model looks like this: y is equal to beta naught plus beta 1 x1 plus beta 2 x2 and so on, beta and xn plus error term. So y is the dependent variable, x1, x2, and so on. Xn are the independent variables. Beta naught is the intercept or the constant term. Beta 1, beta 2, beta n are the coefficients, and e is the error term. So this is the basic consideration regarding the types of regression. So if we consider simple regression analysis, we need to use the example 3 data that I have already shared with you. So first of all, you need to understand the example 3 data. I need to open example 3 data. Let me open it. This is the data set that I have shared with you. we need to open it, example 3 data set. This file has already shared with you. So you need to open example 3 data set for today's consideration for this particular example that I am going to explain. So meanwhile it is open, let us discuss the example 3, what it is, and what are the specific details of this example. This file, which is known as example 3, co- consists of, let me open it. This file, which is called example 3, consists of a data set in which 73 students are measured on their level of pre-exam anxiety on known to severe. It means 1 indicates there is no anxiety, and 10 indicates there is severe anxiety. Uh, uh, and then measured on a 100-point scale exam. This hypothesis for a linear relationship might be that those with very low anxiety will do poorly because they don't care much, and those with high anxiety will do better because they are motivated to spend time in preparation. The dependent variable or criterion variable is exam score, and the independent variable is anxiety. In other words, we are attempting to predict the exam score from the anxiety score. Among other things that regression accomplishes, it is able to create a regression equation to calculate person predicted score on the exam based on their on her anxiety score. So I need to show you the data. If you see the data set, let me show you. Here is anxiety and exam score. This is the independent variable because we are going to see the influence of anxiety on the exam score. And both are continuous variable. If we see the shape of the data, you will have a data range from 1 to 10. 1 indicates there is no anxiety, while 10 indicates there is severe anxiety. So as the value of anxiety increases, it means it is increasing the level of anxiety. And this is the exam score. So we need to run the analysis, and before that we need to create some hypothesis. There are two types of hypothesis. You can create the non-directional hypothesis as well as directional hypothesis. Non-directional hypotheses are those hypotheses where the literature does not provide any direction about the given set of variables, whether the independent variable increases the dependent variable or whether the independent variable decreases the dependent variable. So when the literature does not provide any support for increasing or decreasing your independent variable impact on the dependent variable, we can consider it non-directional hypothesis. And in that case, we need to create null hypothesis. There is no impact of anxiety on exam score. An alternative hypothesis, there is an significant impact of anxiety on exam score. While in case of directional hypothesis, the literature provide you some direction, whether your independent variable basically increases the dependent variable or whether it decreases the dependent variable. So whenever you have some support by the literature regarding the impact of your independent variable on dependent variable and its direction, then it is directional hypothesis. Like in this case, you can see the null hypothesis, the higher level of anxiety does not significantly increases the exam score. The alternative hypothesis is the higher level of anxiety significantly increases the exam score. So you are predicting that higher level of anxiety basically positively impact the exam score. So this is direction. This is the positive direction. While in the previous case, there is no direction in non-directional hypothesis. So the difference is between uh, the directional and non-directional is the sport of some literature. So what you need to do, you go to analyze, you go to regression, and you select the linear as in order to calculate your uh, uh, basically regression, simple regression. So you need to put your dependent variable in the dependent list. your independent variable in the independent list, and then you need to click on the statistic and you need to verify the estimates are checked and model fit are checked, while the remaining at this level are not required at this level. But if you need to check the descriptive as well as collinearity diagnostic, Durbin-Watson, etc., you can also check them. But at this level, at this point of time, we does not require to check them. We will perform the Durbin-Watson and collinearity diagnostic at the time when I will discuss the assumptions of regression. So at this level, you just need to verify estimates are checked and model fit are checked. And after that, you will find out these results. You need to identify what is the value of R from model summary, what is the value of R square. Then you need to see from ANOVA this value. This should be less than 5%. And then you need to see the impact of your independent variable, especially the beta value. If it is positive, it means it increases your dependent variable, and the t value should be greater than 1.96 and the p value should be less than 5%. So let me show you some practical procedure here. As we have the data, we go to analyze, we go to regression, and then we check the linear. We need to put the anxiety as an independent variable. We need to put the exam score as a dependent variable. Then we go to statistic and we need to verify that estimates are checked, model fit are checked. Click on continue, click on OK, and you will see these three tables. First of all, you need to see the model summary table. The R indicates the correlation between dependent and independent variable. So here, the value of correlation between independent and dependent variable is approximately 49%. It means the 49% variation in the dependent variable, which is basically exam score, is explained by the anxiety. And then there is R square, it is approximately 24%. It explained that the variation in the dependent variable is 24% explained by anxiety. So R indicates the uh, uh, v, uh, R indicates the moderate positive association between dependent and independent variable, while R square indicates that 24% variation in the dependent variable, which is exam score, is explained by anxiety. Then you need to see the significance value of ANOVA. If it is less than 5%, it means your model is statistically significant. Then you need to see the coefficient. Here you need to see the coefficient of independent variable, which is beta. So here you can see that the independent variable, which is anxiety, is indicating a positive impact by a coefficient value of 2.818, and the t value of this coefficient value is 4.710, which is greater than 1.96, and the p value of this impact is also less than 0.05. So we can conclude here there is a positive and statistically significant impact of anxiety on exam. So what we can conclude here, we can conclude that if we increase the anxiety score by 1 unit, it will increase the exam score by 2.818 because there is a significant impact. So we need to interpret the results here. Let me show you this one. So what we conclude here, I need to write here the interpretation, and I need to select here the text color like dark blue. The results indicate that uh, 1 unit increase in anxiety, a 1 unit increase in anxiety significantly increases the exam score by 2.818. So if we increase the anxiety by 1 unit, what does it mean by 1 unit? If you see the data, here, this is the anxiety score. These are units. So if we increase 1 unit in anxiety, it will increase the exam score by 2.818. So this was the hypothesis that whenever we increase the anxiety of a person or anxiety of a student, or increasing the anxiety of a student will also increase their exam performance. It was the hypothesis here. So the higher level of anxiety significantly increases the exam score. So it is basically as per directional hypothesis, the null hypothesis is rejected and alternative is accepted. And if we see the non-directional, there is a significant impact of anxiety on exam score because the impact was significant. So here you can consider it. So these are basically the interpretation of different parts, as I have already indicated, that in the summary table, if you see the summary table, model summary, the first R value is basically the multiple correlation or correlation between the dependent and independent variables. So since there is only one independent variable, the number is bivariate correlation between exam and anxiety. It is both the test statistic, vagara, test statistic, etc. So you can consider a positive, moderate positive correlation. Then there is a R square. R square explain the proportion of variance in exam accounted for by anxiety. So there is 23.8% variance in exam explained by anxiety. You don't need to interpret the adjusted R square here because these are the only thing that you need to consider. Then from ANOVA, you need to consider the SIG value, yes, significance of X. So likelihood that the result could occur by chance. So we can say that it is a statistical significance, the SIG value. So this value should be less than 0.05. Then the next one is basically the beta. So if you see the beta of the anxiety, this value indicates that there is a positive impact because this value is positive 2.818 and the p value is greater than 1.96 and p value less than 0.05. So there is a significant impact of anxiety and this significant impact is positive here. So this is how you can consider the simple regression analysis. Next is example number 4. We need to consider example number 4 data. So let me open the example 4 data here from this file like this. We need to understand the procedure of multiple regression here. When we increase the independent variable more than one, it becomes multiple regression analysis. So here you can see there are a number of variables here. There are a lot of variables here. So we need to see what are the guidelines for example number 4 so that we can consider multiple regression here. Now complete the similar procedure for two relationships shown below. The influence of closeness and closeness squared on life satisfaction, and the influence of attributional style and square of attributional style on life satisfaction. So if you see in case of both of these relationships, the dependent variable is life satisfaction. If you see the on the above line, the life satisfaction is the dependent variable, and in case of the second relationship, the life satisfaction is the dependent variable. While in case of the first regression, the independent variable is closeness and closeness squared. And here in the second one, the independent variable are attributional style and squared of attributional style. So first of all, we need to find out the dependent variable, which is L satisfy. So let me open the file. and go to analyze, go to regression, go to linear, and then I need to find out the dependent variable. If you see this in a long form, you can click on Control A from your keyboard and then right click on it and display the variable name. You just need to check it, display variable name. Now it becomes the short form. Now you need to find out L satisfy from here, which is the life satisfaction. So we need to find out this is the L satisfy. We need to consider this as a dependent variable. Now, what is the further thing that we need to find out? That is closeness. And it will be indicated by close. And we also need close square. So close, we need to find out this is the independent variable. We also need close square. So we need to see where it is located. Close square. This is the close square. This has completed the first part. Then we also need to have influence of attributional style, ASQ, ASQ and ASQ square. So we need to find out from here ASQ. First of all, I need to see ASQ. This is ASQ. Put it in the independent variable, and then we need to have ASQ square like this. Now it is completed. We need to see the statistics. Estimate and model fit should be checked here. Then you need to click on OK button, and here it is. If you see the R, it is approximately 37%. It is a weak positive correlation between dependent and independent variable. Here, the number of independent variable are more than one. So we can say that it is multiple correlation. It means there are more than two variables which are correlated. So it is multiple correlation. Then there is a R square, which indicates that your independent variable, which is ASQ, close to ASQ, amount of physical closeness, they are explaining the dependent variable, which is life satisfaction, approximately 13.5%. Then if you see the sig value of ANOVA, it should be less than 5%. So it indicates that your model is statistically fit. Then if you see the coefficients, here ASQ or the amount of closeness, the amount of closeness or close is negatively and weakly. If you see the sig value, the t value is less than 1.96 and the sig value is greater than 5%, but less than 10%. So we may consider it weak significant. So here the amount of physical closeness negatively influence the life satisfaction, negatively and weakly influence the life satisfaction. Then closeness square, it is significantly increases the life satisfaction. It means if we double the amount of physical closeness, if we double the amount of physical closeness, it will increase the life satisfaction, significantly increase the life satisfaction. Then ASQ, what is ASQ? ASQ means influence of attributional style. So what does it state? It gives us positive but insignificant impact because p value is very high. And in the same way, ASQ square, it is also not significant here. So what we have concluded, we concluded here that if we doubles the amount of physical closeness, it will increase significantly the life satisfaction. So this is the conclusion of these results. This is multiple regression model. So for your convenience, you need to consider example number 5 and example number 6. What is example number 5? The dependent variable is z help. The standard score z score for the amount of help given by person to friend in need on a -3 to +3 scale. Sympathy, feeling of sympathy aroused in the helper by friend dad. anger, feelings of anger or irritation, efficacy, self-efficacy, severity, helpers, rating of how severe the pen problem was, and important empathic tendency of helper as measured by personality test. So we need to open the next file. Let me open the example 5 data. You need to practice these data at your own. So let me open it. The data set is open. First of all, I need to identify the dependent variable. It is z health. So let me open analyze, regression, linear, z health here, like this. I need to put it on dependent variable, then sympathy, anger, efficacy, sympathy. This is sympathy, anger, and what was the next one? Anger, efficacy, severity. This is efficacy, then severity, and what was the last one? Important. So I need to put it important. Yes, this one. So it is completed in statistic, estimate, and model fit are there. So click on OK, and here it is, the results. If you see the R, it is showing a positive, a strong positive correlation, a strong positive multiple correlation between the variables of the study. Then R square is approximately 40%. It means important, efficacy, anger, severity, and sympathy. They are basically explaining the variation in Z health by 40%. Then you can see the model fitness. ANOVA indicates that the model is statistically fit because this sig value is less than 0.05. Then you can see the impact of independent variable. All are significantly impacting except the severity and important. It means sympathy, anger, and efficacy. They helps to increase the Z health significantly because the t value are greater than 1.96 and p value is also less than 5%. So what is Z health? It is the standardized score for the amount of health given by a person. So we can say that amount of help given by a person basically increases by sympathy, anger, and efficacy. So this is basically the result of this regression analysis. The last example that I am going to discuss with you here, let me open the next file. The next file, which is the last file, is example 6. Use the example 6 file for exercise that follow, conduct the following three regression analysis. So we have considered that we have three dependent variables. So we need to consider regression using three dependent variables. So the T help NZ, time spent helping, T qualities, quality of the help given, to help, a composite help measure that includes both time and quality. So we need to consider these three dependent variable and these are independent variable. So except these three, we need to consider each of the following as a independent variable. So let me open the file, the example 6 file. After it is opened, you need to see first of all your dependent variables. We help NZ, LNZ. So you go to analyze, go to regression, linear, then you click Control A and make them display variable name. And then you need to consider your dependent variable, and always remember that this procedure allow only one dependent variable at a time. You can consider multiple independent variable, but you can consider only one dependent variable here. So what was my first dependent variable? That is the T help LNZ. So I need to find out T help LNZ, T help LNZ. This is my dependent variable. Now I need to consider independent variable, for example, age, injured, and so on. We can consider age, and what are the next? Injured, yes, this one. Then what is injured? It is the amount of anger felt by helper towards the needy friend. Then affect, helper's feeling of self-efficacy, affect. So I need to select it, affect. How it is started? E, with E. Yes, this is a fit variable. I need to see, yes, this is the composite affect variable. Then the next one is empathy, that is helper's apathic tendency, empathy. So I need to select it, this one, empathy. Then the next one is gender. I need to select the gender, this one, as an independent variable. Then H close, that is helper's rating of how close the relationship was, H close. So this one is H close. And the next one is H control, which is helper rating of how controllable the cause of problem was. Uh, H control. And after that, H perfect. Let me visible. Hold on. So H control, H control. I need to find it the variable from here. H control, H corporate we have found, while H control we need to see. Yes, this one H control. Let's suppose these are the number of variables that we require to test. So just click on OK, and you will find that some of the variables are automatically removed from the system. The R is 0.52. There is a positive correlation. There is a positive multiple correlation. Then R share is 27.2%. It means your independent variables are explaining 27.2% variation in the dependent variable. Your model is statistically fit. And if you see the impact of different variables, the age is positive and statistically significant. The mean rating for 4 anger questions is also statistically significant and positive. The mean of 14 efficacy measure, this is also positive and statistically significant. Then mean of 14 empathy questions, they are also positive and statistically significant. Then gender, it is negative and statistically significant. Then helper rate closeness of relationship, this is positive and statistically significant. Mean rating of 3 helper coping questions, this is negative and significant. Then helper mean rating of controllability, this is negative and not significant. So this is how you can consider the multiple correlation. So I hope you have understand. You just need to do more and more practice to apply the simple correlation and multiple correlation. In the next session, which is going to be held on Monday, we will cover the regression assumptions. There are some assumptions that need to be considered for validating your estimates. Whatever the results you have generated, whether those results are valid, whether those results are efficient enough to interpret or to make some prediction or to make some judgment or decision. So we need to find out the validity of assumptions, whether the assumptions are accepted or not. So whenever you are going to run a regression and you find some impact of your independent variable on the dependent variable, you need to verify the impact, whether it fulfills some certain assumptions or not. So this is the topic that we will cover on Monday. So do you have any question, both of you, Ms. Rabia and Ms. Sina? Please let me know.
No, sir.
All right, just do practice and we will discuss the next topic on Monday. Thank you very much for joining. Stay blessed.